Hi guys, this is the notes and another example of finding an angle in a triangle. If you look at it, the heading is finding the angles in a triangle. The idea is, the key understanding is that you use inverse trigonometric functions to find angles if you know the sides of a triangle. So regular trig functions, sine, cos and tan, are used to find sides. But if you're looking for angles, it's sine inverse, cos inverse, and tan inverse. Okay, so you may want to pause there and write that down. But if you're ready to go, let's just move on with the example. If you look at the triangle that I've given you here, it's got sides 2 and root 3 on the hypotenuse and the adjacent side. And the angle that we don't know is called alpha degrees. So what we need to do is write down what sort of a trig ratio it is. So we're going to be choosing from SOHCAHTOA. And if you look at it, we've got the adjacent and the hypotenuse, which makes it a cos ratio. So that means that cos of alpha must be equal to adjacent over hypotenuse root 3 over 2. That means that alpha must be the inverse of cos. We're working backwards to find the angle. We were given a cos ratio, but I'm looking for an angle. So I'm going to say that it's cos inverse of root 3 on 2. I know it looks like cos to the minus 1, but if we were going to write cos to the minus 1, you'd actually have that out here. Okay, and it would be the inverse. Put it on the bottom of a fraction. But when it's in next to the cos, it actually means the inverse of cos, so working backwards through the cos relationship. And of course that's something you can do with your calculator, so you pull up your calculator. You make sure it's set to degrees, not radians. You should see a little D there. And you push shift cos, which gives you inverse cos. You see the little minus 1. And then it's going to be square root of 3 root 3 on 2. Close the brackets, push equals, and it gives you 30 degrees. This root 3 on 2 is one of the special cos ratios that give you an exact number. There's only a few of those. I thought I'd show you one. But that's it. Inverse cos of the cos ratio gives you the number of degrees, and that's what you need to know.